Happy birthday, Joyce! Merry Christmas!
Happy birthday!
Are we gonna sing for her? Are we gonna sing for her?
Let's sing. Happy birthday to you. Happy birthday to you. Happy birthday, dear Joyce. Happy birthday to you.
You better not have skipped it.
Yeah, seriously, Joyce. If you skip it, we will hurt you.
Like our changing.
Fine, Joyce.
Joyce's birthday, we're not gonna hurt her.
Alright, here we go. Notes open. They just want to waste more time. They were talking about UCLA before. Okay,
No,
so.
Brian, you got accepted. And,
How do you know she got accepted?
because it's Joyce. Who's gonna decline her?
Apparently, Stanford.
No, she hasn't heard back yet.
It's not about.
Should we stop this recording?
That's why I asked.
Should we delete that part?
Wait, what did you just say?
He's like, yeah.
They're jealous.
I'm smart for
It's
me.
okay.
I am jealous, actually.
You wouldn't be if you did your homework.
Yeah, honestly. Once I got my UC Davis rejection, I was like, sure, try harder.
Davis is in like Sacramento, isn't it?
You don't want
Yeah,
to do Davis.
But like in Davis, my uncle works in the Capitol. I would be able to intern in the Capitol.
I get it.
And then like I have family in SF.
Who would have been
I have a
prime
cousin that
location?
goes to Davis.
Okay, I didn't know backstory.
But like, you know, I think it's
Does anybody know anybody
Yes.
besides me? Anyone besides me have anyone that they know that goes to UC Riverside?
my
My
mom
sister
went there.
graduated.
I think Derek Cruz was
There
My
were a
mom-
few
my
kids
mom-
that did like 3 years back, 4 years back. There's a whole crew that went down there.
I think I have a friend, like a family friend, that goes. She goes there or Irvine. I can't remember.
Alright, you guys should be solving. Yep, I cut it off. Okay, so.
See, earlier we were talking about how we're all gonna try to get 5s, but you know, like some of us don't know how to count. So.
I don't know how to read.
Like literally right now, we were talking about percentages, and I was like, oh, 8 out of 10, 8%. So,
That's just maybe like you're speaking quicker than you thinking.
and then Racha was giving me a math problem yesterday, or somebody said something like something times something. I was like, oh, it's this. And I was like, that's not even close. But I'm really fast. It's not with the right answer.
It's like when the math teacher lost at the math challenge game and the whatever my brother-in-law and all of his friends were playing it. It was a struggle. They were bragging on me though, they got me all psyched up.
So how do you do this?
This was your formula where you did everything first.
No, it's
and
a
then
horizontal and vertical.
And
Yeah, see
then
nothing.
equal.
Right, but
And then equal is your
we're gonna find like,
Second.
oh, right,
There
right,
you go.
right,
There
right.
you go.
Second. Oh, I did this backwards. Second first.
Yeah, nice.
Yeah, that's right.
Back.
True. Minus sine theta plus sine squared.
Cosine squared is 1 minus sine squared. So then you can have 1 minus sine squared minus sine squared.
Wait.
Oh, minus sine.
Oh, see, it was just copying what you did.
You could do that.
But if it was on the AP test, I'll get a 5 guaranteed.
what I want to do.
Well, that's some of the worst one I have to take. I think I'm done with my good college. Pretty fun.
I don't know.
Oh, that's right. You're the lifer.
You guys back me up?
Yes, fully.
I'm not following the bottom part. Oh, I see, but
I just changed it because it was going to be
Yeah.
cosines and sines. I want a quadratic with just sines.
okay.
Pretty counting.
I almost killed it. Then we can just let me just offer
When is sine 1/2
pi
over 6 plus pi? No, plus pi over 2. And
and cosine was cosine equals 0 pi.
wait, no. Wait, it's horizontal and vertical tangents.
Wait, don't we have 2 for the top?
True. But can these both be true at the same time?
I don't know. I haven't done it.
Because horizontal and vertical tangency,
Oh, so it has to be at one point?
the point,
both.
so both top and bottom needs to be 0.
Wait, you can do it on the bottom one. 2 sine theta, right? Plus 1, and then since we have the negative.
True, but this one, sine's going to equal positive 1/2 and negative 1/2 at different places. And neither of those are going to make cosine
If we
0.
have the distributive, we distribute the negative, and it's not positive.
But it would distribute to both. So then,
Oh, and you.
yeah. No.
Okay.
So then what I zeroed in on was when was both 0. Sine is -1 and cosine is 0 at 3 pi over 2.
Wait, can you say that, can you say 2 sine of theta plus 1 times sine of theta minus 1 instead?
You have to bring in negative to both, so it'd still be 1 sine left.
No, like the original factor, it was 2 sine of theta plus 1 and times sine of theta minus 1. And you put the
original factor. No,
No, you
that
can't.
wouldn't have been the original.
Okay.
It would have been -2 sine of theta plus 1. Right? Because you have to bring the negative into both.
I tried.
So we have 1 plus -1. Oh, I'm putting that in there. Because sine of 3 pi over 2 is -1. So 1 plus -1 times. And for x.
Don't they want R and theta, not X and Y?
Oh, that's probably deeper. Thanks. I didn't keep reading the problem. It's okay. You can't count. I can't read. Okay, so.
Oh, I can't read either. That's my gut read.
Can't or don't like?
Well, I look at the question, I read half of it, and then I stop reading and I go get the answer that supports half of the question.
Bless you.
Thank you.
No.
I feel like you already mentioned that.
I like.
You got it?
Yes, ma'am.
I just want to know how you got that. Like, how do you know that it's 3 pi over 2 is the angle?
It could be -pi over 2. It could be 7 pi over 5 pi over 2.
Either way, so it's the same point.
No, like, how'd you know that would be?
7 pi over 2.
How'd you know that would be
Oh, because one is cosine 0 and sine -1 at the same time. 3 pi over 2.
okay? And R is
Plug it in, plug it in.
ha.
Does that make sense?
Hmm?
Sorta, kinda. Kinda, sorta. Ooh!
Make a table, yay!
How do we sketch those graphs?
Not one at which to eat. LOL.
How do we make graphs?
The table.
Plug 'em in, plug 'em in.
We actually have two options, just before I make you guys go make tables, at least for a couple of them. You do have options. You could memorize all that.
Yay!
But I don't want to.
But we used
But it's not going to be that many on the exam. But once again, you could memorize all that. The roses versus the limasols versus the circles and lemniscates, and their orientations. Or, use the unit circle.
memorizing it is. Told you I don't have to count.
You need to count for that unit circle.
Yeah, you do. 2 out of 2. Zero. 5 or 6.
Now, pause. Which numbers are we going to like sign equaling, and which numbers are we not going to like sign equaling?
0, 5 or 6.
We like 1 and negative 1. We like 0. We're going to like 1/2 and negative 1/2. What angles are we probably going to avoid then? The root 3 over 2 ones? And root 2 over 2 ones, if we can. When is sine 1/2?
5 or 6. So not 5 or 3. Not the other one. 5 or 4. We want 5 or 4. Is that 1/2?
If we need more, we can get more, but let's just do the first quadrant and see. That sound good?
Sure.
Okay. So sine of 0 is? 0.
Minus
1 minus 0 times 2 is 2. True? Hey, if you want, you can start building your sketch at the same time. True. Question, is this ever going to be any bigger than 2?
No.
Can't
5
sine
or
equal
2.
negative 1? So then 1 minus the negative 1 will be 1 plus 1. So you have to think about the range. If sine equals 1, it's going to go to 0. If sine equals
3
negative
times
1,
2.
it's going to go to 4, right? So we'll go ahead and... Good thing we reviewed polar earlier.
Good thing we're gangsters.
Okay, so at the 0 angle, we're going out 2, right? Okay. Pi over 6 would be 1/2. 1 minus 1/2 would be 1/2. 1/2 times 2 would be 1. True?
Oh, there we go.
Does that make sense? Ish. And then pi over 2 sine is 1.
So
1
0.
minus 1 pi to 0.
It's gonna have a little
You
curly
guys see it
thingy.
go whoop, whoop.
Gonna have a curly thingy.
Now what? 5 pi over 6.
It's
Positive 1/2 again, so it's going to be 1 again. Oh.
Can I still draw circles?
You guys know how this is curling, right? The 1 to 1, we have to draw on that line, like a polar. Making sure we reviewed that earlier, but I double check. We're not going up 1, we're going around 1. And then at pi, what's going to happen?
4.
Sine is going to be 0, so then 2 again.
Probably
It's
gonna
like
go
a
on
heart.
this
It's like a fat heart.
It's not going to be a landscape.
state.
It is going to be a fat heart.
Yay.
Because, can we figure out,
Oh,
We said,
it's origin
when
axis.
is sine going to be negative 1?
3 pi over 2.
Sine is negative 1, that's 2, and 2 is 4. You see it?
If we draw one side, we
Polars are almost always
flip it.
symmetric to some shape or degree or form.
Yay, cohesivos. Now we don't have
But I
to
just
do
don't like
more.
that one. My units weren't very evenly spread. I apologize. It's kind of
It's okay, we forgive you.
just pretend. Yeah?
We forgive
What is that technically?
A heart.
Called
Go to the next page.
the cardioid.
What did you
Cardioid?
I'm fat.
Oh my goodness. Okay, so what about the next one? Ready, set, your turn, go.
How's it going?
Oh, come on!
Is she funny?
Come
Isn't
on!
she funny, Joyce?
She thinks she's funny.
Grace is
She's
laughing.
calm.
I'm not sure if she's laughing at me right now.
I wonder what she thinks of class or how ridiculous we are.
Okay, shh, focus.
Oh, things are very good.
I bet that's what she thinks. I don't know what she watches. Videos.
I feel like she like
Probably
turns
puts
up
it
the
on
volume.
mute,
Yeah.
I know that sometimes I look back and she's just kind of sitting twirling the chair, like, okay, wow. She's listening. How about you guys making your graph for number 13?
Okay, so the max can be is 2 threes.
Good. Right? Because the max cosine can be is 1 to make everything maximized.
Remember when Mr. Crawford used to have like the little graph and all you had to do was double tap at the point and then it would create the dot? And then it was like literally perfect. And then,
Yeah, because he had his like oriented with 16 points of accuracy. You guys aren't using pi over 6, right?
No, how?
Good. Because cosine of pi over 3 is 1/2. So it's like-
How did you get?
It would be root 2 over 2.
And then you
Think
get
about
the,
root 2.
and then 1 plus root 2.
You get these awkward decimals that you have to figure out, which is okay, these awkward
It's
decimals.
just a little more than 1. 0.
No, a little less than 1. Oops.
See, that's the problem.
Is it a little more? No, I think it's a little less. It's like a little more than 1/2.
For 2 pi over 3 is 0, right? I'm not crazy.
For pi over 3, why did you go over 2?
Ah,
Go
because
to-
remember, at pi over 3, we go out the radius of 2.
So I'm
That's
gonna
right.
draw a little something.
That's why I do this. Because otherwise it's impossible for me to get it. Do we ever have to graph them on the AP?
You might have to do a polar area, you don't have a function. Like you don't have a
So, like, but do we have to, like, you know, if
they're not
we
going
draw
to give you
slope
points
fields,
for graphing.
you know, like we have to draw
Yeah,
slope
they're not going to give you points for graphing. It's going to just be necessitated same content.
We issued to drop slope fields?
Every now and then, depending on the FRQ. It was on the FRQ though last year, so probably not this year.
Yeah. Wow.
Probably be a matching and then a multiple choice, but it's the same possible. Cosine of pi, we already got that one right. -1, would that be a -1? -1? How do we do that?
Up 1 to the bottom is. No.
Go in.
And
Remember, you go backwards for negative.
So you go,
Yeah, that's a linear sum.
Yeah, it's a mean sum. And if you notice, it's going to have the same symmetry without us having to like really do too much. Because
Wait,
cosine
that's
has
not-
what kind of symmetry?
Even.
Yes, well,
Let's say even. Is it odd? Then it's
It's even.
Oh, so it
And
wasn't.
what's cosine curve look like?
see, that's also the problem. I don't know what the cosine.
Oh
I always get confused between sine and cosine.
Okay, hold on. What's cosine? Ready? What's cosine of 30?
Hi.
Oh, wait, yeah.
Let's use.
Sorry. What's cosine of pi over 6?
Square root.
Square root of 3 over 2. What's cosine of negative pi over 6?
That was rough.
Still square root.
It's even because you go up and you go down. It has, it's the same.
Wow.
Go like this.
Does that make sense? So go negative,
So
go
you go
positive.
You just stay there.
Sine, you go negative, you go
That's-
positive, it's going to be the opposite.
I don't like sine. It's a big pain in the neck.
So, hold on, pause. What cosine is, look at polar. Look, eyes up, eyes up, eyes up. When you go up, cosine's value will be the same as if you go down,
Alrighty.
right? Look at sine. Look at sine. If you go up, or if you go 180 minus, first quadrant,
What did you
second
say?
quadrant, it's going to be the same.
180 minus.
Sorry, pi minus. Arc sine.
What's I don't know. Just stuff. I don't know.
Sine of the first quadrant of an angle and sine of 180 minus or pi minus, same angle is going to be equal. But you guys stopped once you got it? Hold on, number 14. Yes, we're working on these
Why?
because you don't like them and I'm not sure you're good at them. So let's go.
We're not to be good at
That's
everything.
mean.
Mr.
No,
Wells
that
said.
means we need to master it.
Mr. Wells says just because you're good at something doesn't mean you're great at it. You have to be passionate about it. So I'm not
Question.
passionate about it.
Isn't it love to see a weakness and then?
Yeah, it's not hate, it's
Come on,
feedback.
Mr.
Oh,
Oh,
Mr. Will,
okay.
or because Mr. Will said,
John Acuff, baby.
Oh,
John Acuff.
true.
John. Oh.
It's not going to point out error.
Twitter.
Is this error or is this like punishment?
Not error, maybe.
A little bit of
Okay,
both.
so now since it's 2 times whatever it is.
No, that means it's like so. If you
But
put,
doesn't cosine still go between 1 and -1? How big's our graph?
wait, what?
Vegas 4.
Yeah.
Go ahead and figure
4 and -4, true? Is
Mhm.
cosine have a -1?
Yeet.
We're not gonna get into 3D derivatives and stuff, right?
What?
It's like XYZ.
That's like more calc 3.
We are Calc 3.
Go team.
Aren't we like technically Calc 1.5 because this is like Calc 1 and Calc 2?
No, it's like how in algebra 2 you used to learn algebra 1 stuff.
Oh yeah.
Question, why am I still going to go by pi over 3s, but I'm also going to go by pi over 4s?
Because you're gonna reduce. So pi over 4 would be
2 times pi over 4, good. Is it pi over 2?
Yeah, I think about college. Honestly, I've been freaking every day. I check like a religion
Guys, I have to start class. Why did we end class talking about that?
Because
we
it's
usually
like
don't finish our lessons.
that's what it feels like. See?
So like, if we don't finish our lessons, that means we won't have time to cry about college. We gotta start before.
Yeah, we.
Cry
always go right
and
to
not
that.
finish.
Now I'm talking. Come on. Sometimes it's nice to be able to not focus on life, but focus on math.
Math, I always focus on
Do you
that.
do unit circle and college at the same time? I don't think so. Here we
I
go.
think so.
Zero.
0. I'm not getting into college.
Cosine of 0 is 0?
No. Go
Good.
to pi.
Cosine of 0
1,
is?
4.
4.
1. 1 times 4 is 4. You guys once said 0.
I meant for pi over 4.
Well, I wasn't there yet. I
I
said 0. So, I have 4.
4.
Cosine of pi over 4 plugging
Zero.
in is pi over 2 is
0.
2 pi over 3.
Wait, so pi over 4 is
I'm
not.
not getting into any colleges.
2
Get it?
for the next one.
So I couldn't do it.
Pi over 3 is 2 pi over 3, which is -1/2, which is -2.
What?
Right?
What?
Plugging in pi over
Oh,
3
no.
is 2 pi over 3. Cosine of 2 pi over 3 is -1/2 times 4 is -2. You guys are scaring me.
Don't be scared. You have Joyce. You have Joyce. You're right.
How does that make sense?
I don't know.
Wait a minute.
Also, how do you
Oh,
draw that
no.
line?
Oh, you extend the
No,
pi
not the
over 3.
line, the curve, sorry.
Oh, 2 to 2.
No, like with the 3 points.
Oh,
You didn't connect them the way they were drawn.
Oh, how did you know it goes up?
I would like to get another point first
Because
before
are
we
they ever
totally
straight
connect.
lines?
Got it.
Hold on.
Or top?
What's pi over 2?
Pi.
-4.
-1, -4.
Yeah, equations. Some of this.
Oh, so it goes back. Wait.
No, just go like.
It's going to go back
Oh,
on
because
itself.
it's still pi over 2. Okay, I was thinking half pi.
2 pi over 3. It's going to be 4 pi over 3. That's the third quadrant. Cosine is still -1/2, so still -2. Three pi over 4? 0 again, true? And cosine of pi would be 2 pi, which would be 1, and 1 times 4 is 4. So then 3 pi over 4 will be 0. And then pi will be 4.
Ooh, looks like the Saints logo, kind of. Not really. Oh wait, can we finish it? Is it done?
Not done.
Oh, we just gotta bring it through.
It's gonna be a rose.
Oh, no.
But how many petals? What do you guys think?
Okay, so it's 2 theta, so it's gonna be 2 petals. No, I don't remember how it works.
Cosine. So what's up is gonna be down.
Oh yeah.
So you can just draw the rest of it?
And what's down is gonna be up. As long as there's not some nasty theta times out here that's gonna make it ever increase like a spiral. That happens every time. Because if there was a theta outside, it doesn't matter that the cosines are oscillating. If it's times a bigger and bigger theta, then it's going to be growing. That's where things get messy. But if it's just the theta inside a string, then yeah, we can use this.
Wait, we can do area under the curve of that? Is that what you're saying? Polar area? How do you do that?
Very careful.
Una más.
But wait,
No.
it's 0.
Hell, no.
Una más. R squared equals,
Oh.
R squared equals, that was fun. It's based on a sign, right? In between 1 and -1, are we still going to use
Wait, shouldn't we do
a 4x4?
Shouldn't we do the root then? Just to get our right?
No.
I don't know, the root can be empty.
Wouldn't it be 2 since the max QB is 4 and you square root that, it would be 2 to the max you can go.
Are we rooting them or no?
Oh, I'll just look at the right hand side, sorry.
4 side 2.
So sign can be between 1 and -1, Jordan is right. So between 4 and -4 is the value. So R squared is going to equal, hold on.
-2, -2, because it's always going to be greater than -4. And it's plus or minus square root.
Yeah, so based on going between -4 and 4.
You saw something that we didn't see it, and you said ooh, and I'm kind of scared of what's going to happen.
That's okay. Let's plug in.
Oh, dang it, it was D.
We're still going to use pi over 4 because we have 2 theta, right? So then those will be
Is
pi
it a
over 2s.
circle?
But we're going to use pi over 6s again.
I feel like it's a circle.
So we have 0. Pi over 6.
Pi
over 4. 5 pi over 6.
Feelings
So
in a
it's got
second,
pi
George,
over
don't forget.
And R is 4, so that
two.
means
He
R
made
is.
my
Is it?
goal.
Is it a
I'm
circle?
trying to distract.
I know.
Okay, sine of 0 is 0. Square root of 0 is 0. So that's easy.
Yay, 0. Oh, it's not a circle. Dang it. It might be, I don't know.
Then what? Pi over 6. 2 times pi over 6 is pi over 3. Ah!
Feels above.
1
Sun
pi
died.
over 6s.
Sun died.
Nope, we're going to try and
Okay,
skip it.
fixed it. No more pi over 6.
Oh, Misty.
Wow. That's crazy.
Cross it out.
It's power G.
And pi over 4.
Pi over 2.
Or pi over 2.
Let's see how much
Are
farther.
we still at pi over 6?
So pi over 4, yeah, because 2 times would be pi over 2.
Oh.
So sine of pi over 2 would be 1. 1 times 4 is 4, and 4 square rooted is 2.
Sine of pi is 0.
Technically plus or minus 2.
Yeah, that's we have double the points every time. Shandai.
Pi over 2 would be sine of pi, and sine of pi is 0.
This is easier than we think.
3 pi over 4
3 pi over
is
2.
3 pi over 2, which is -1, which is -4.
Done fine.
What's our square root of -4?
Undefined. Does not exist.
What is this thing?
Feels above.
It's just a little infinity sign, kind of.
The airplane pedal thingy.
Love this game.
I think. How can we know for sure?
Plug it into our calculator.
Yeah. Well, let's go look at our table-y thing.
Okay.
When's the lemniscate happen? When r squared is equal to some constant times sine.
Ah.
When's the other lemniscate happen? When r squared equals something times cosine. You see how cosine
So
still
it's
shows
not a
its symmetry
circle.
though? And how sine still shows odd symmetry?
Dang, it's so
It's not a circle. A circle is if you just have r,
Can we get
not r squared.
Can we get which one called ellipse? So if we did like r equals
No, you
a
could, I
cosine
think-
like 2 theta? It's not a squared theta or a squared times that?
You need to be squished.
What's the difference between the circle and a convex? Like, why it's not the right?
Technically convex, is it like,
Like flatter.
this one has like a little dimple, but it doesn't go all the way in. This one just goes flat.
Oh, okay.
So this is like the bottom of an egg. Well, that's more like the bottom. I don't know what it is.
So it goes kind of like.
Something that you have flattened so you can put on a something.
A
Okay.
floating wine cup.
Nicaragua, like the candle things, like that. It's like, that doesn't help most of you though. All right, so moving on.
Doesn't help the guy that won you
What?
I don't remember exactly.
The potter.
I didn't memorize that.
Potter
for-
had those
Yeah,
like
I did
those
use it
ID
once.
things
So
that would go over a
useful.
candle with the
Yeah.
butterfly. Woo! Look, area is a polar isn't due until Tuesday, so we need to finish on Monday, but we do have a test on
Monday?
or Thursday. One of those.
We like next Thursday?
But is that the week of the AP?
No, we have one more week after that.
Wait, just 2 weeks to the AP test?
Till the April 1st.
So 2 weeks until I know I'm going to college.
We're stressing A-Deb out. Come on. Calm.
You're the one that has it on April 1st. Whether
But there's no
I
other
find out
time.
before college.
It's the prom, and the next one is spring break, and the next one is spring break.
You should just make it
And the
coming
next
on
one is
Easter.
the weekend before the AP
Sign up
starts.
for pi over 2.
That's fun. I'd rather practice over break.
Yeah, practice. Good one. This is easier to make me do my forever coding in Baja. Last year I did it, was so boring.
He had the
I had
BC girls. who
yeah,
walked
like
around.
I had everybody in there knew math except for Dylan.
Well, we weren't talking math though. We were talking math.
I was asking questions and Dylan was like, "What is this?"
Dylan Thomas?
Yeah. So at Dylan Thomas.
I don't watch this video.
Come watch this video. We're talking trash about you. Trash.
We're gonna be watch this full
Nah,
half hour.
okay.
Just get to this part.
He says you don't know math because you're a chump, Dylan.
There's
Kind
a
of.
little
I put the
triangle
words in
thing.
there, but no.
I don't like that there's a little triangle.
That's like the area of a triangle.
Triangle's delta. Delta, we can make a differential. Ooh.
What did you just call
Limit as n goes to infinity. That sounds a whole lot like
Feels above.
a change in going infinitesimally thin. Sounds like an integral.
Integral.
That funny,
So I
something
want a
integrating.
little circle with the triangle in it.
Depends on how hard you want your life to be.
Would that make it easier?
Let's see if that shows up. How did I pull that up? Who is R? F is theta. Let's do it that way. That shows up.
It's scary how well that lined up.
So what are we doing? We're taking areas of circular sectors. What's the integral doing for us? Making them infinitesimally thin and accumulating them throughout the angles that we need it to accumulate.
So it's accumulating like little triangles.
Well, but with circular
With
ends, yeah.
Sectors. Like
Yes.
vectors.
Infinitesimally thin pizza slices of varying depths.
We should each
Nothing
get a
better
pizza
than
slice
pizza
for this section.
slices. Except for Jesus.
Wait,
don't.
Hold on.
I don't know the timing for it. For rolling like a tennis ball if you're solar. Or actually
How about now?
No.
No.
You had the little thing. in front of it. There we go. I almost that. Look.
Oh, no, where is it? No. You ready?
I don't think this class has ever felt as long as it does right now. Those tables, they just drag the class out.
Who does it for you?
You ready?
What?
We had this little cylindrical thingies last year.
What's it going to do as it accumulates pizza slices? Well, these are just angles, right? True. We're going to move our way around. Okay. So then,
Wow.
No way.
That's beautiful.
Is that like an actual thing that's possible?
that's what you're going to do when you integrate.
But how do we get
Why?
all the in between?
Hold on, pause. Question, pick an angle.
5/4.
What's the radius? You go out. Find a little baby sector. Accumulate all the little baby sectors for all the different radiuses going out infinitesimally thin. It's like rectangles with rectangular, but it's angles and
I'm
sectors
totally
with
not getting
polar. And how are you going to mark the beginning and end? With theta bounds. Question, pause. What theta did that little leaf end at?
That one.
Who is it?
Pi over
Pi.
6. No, pi over 3.
Pi over 3?
Right?
How long does it take to complete one full revolution?
Pi.
Pi. So what's 1/3 of pi? There you go. So you had it right. So, what if the AP said, find the area inside or enclosed within one petal of this curve?
Do we do any pedal?
You would have to figure out 0 to pi over 3. What would you use as your radius? The
R.
curve.
How would you?
And what would you plug it into? The integral. And the integral would say 1/2 integral of r squared, which is going to be a sine squared, which we're going to use the power reducing formula to find.
Wait, Misty, how do you know that it's pi over 3 besides looking at it?
Hmm.
You have to know it.
The whole revolution.
That's something we're going to have to work on.
But if there's a
But question, hold on, pause. Where does it start?
0?
Where does it end the leaf?
That leaf? Which leaf?
Where does it end?
5 or 3.
No, at 0.
Oh.
So couldn't we set r equal to 0 and find the first 2 zeros? Go team.
Shandai.
So, what if we wanted to do something like this and Gerardo go?
Oh god.
Whoa. Oh, that looks so cool.
Why is it going back and forth? Because graphing would go back and forth. Positives and negatives and positives and negatives depending on the value of cosine or sine.
If there's a theta inside of a sine, like
Oh, that's so cool.
Oh, but wait. Why is this bad?
Because it goes on forever.
double
It doubles up right there. See how it's going to double up? It's going to find area. Double up. This isn't allowed to be chosen twice. Where's the Lima song? Is there no Lima song? Oh, here he is. This is where they like to confuse you. What is the area of just the inner loop? Ooh.
Oh, what?
Just the
Or what is the area in between? Ooh.
Oh,
That's gonna get fun. Gerardo, what was your question though?
If there's like it's like a sine a theta.
Go.
And it's sine squared of a theta. How do you do you use power reducing or like what?
Isn't that interesting?
Or like does a theta act like a unit?
Well, use your power reducing and see what you remains, because in power reducing you usually have a double angle, so you're gonna double the 8. Power reducing, go check out the formula. When you plug into power reducing, there's a 2 theta, so you're gonna double whatever was the original theta. So if it was an 8 theta, then power reducing would become a 16 theta.
So cosine
So
squared.
you wouldn't be 8 theta, you would be the 16 theta after you use the power reducing formula.
So it's cosine squared of 2 theta would be 1/2 cosine. 1/2 1 plus cosine.
No, cosine squared of theta, not 2 theta.
Oh, 1/2 cosine squared of theta. 1/2 1 plus cosine 2 theta.
So if it was a 2 theta cosine squared of, then it'd be a 4 theta. If it was an 8 theta, it'd be a 16 theta.
So you square the inside.
No, you multiply by 2.
Oh yeah.
So for a polar curve, r of theta, the area between the pole and r of theta is given by 1/2 alpha to beta, which is just like beta 1 to beta 2 of r squared d theta, which is the same thing as f of theta squared d theta, where a and b are the angular bounds. And then things get interesting.
Interesting. You interesting or interesting us interesting?
No, it just seemed like the different dilemmas that we just saw. Like, how could you just find the area between a leaf, or between the inner loop of a Lima song, or between the inner loop and the outer loop of a Lima song? We're going to have to worry about bounds, or we're going to have to worry about, well, basically bounds.
I just got real.
The learning in Greek.
That's Hebrew.
Take that, Greeks. You guys suck.
So why do I have a note underneath the endeavor card to find bounds?
Because it's a note that we need to take note of.
Because that's the struggle. Are my 1, 2, 3 the magical 1, 2, 3 to always work? Nope. Are they just ideas that sometimes work? Yep. So what am I going to need you to bring on Monday?
Right.
Your A game.
A game. I would be in the class, so. Just kidding.
That's
I'm
funny.
just kidding. Don't give me a bad look.
That's actually really
It
funny.
was nice.
Misty, I just realized I don't think I got this thing this week. I forgot to
I didn't
I think so too.
I was here, but
I wasn't here.
I came after school that one day.
Yeah, it was like 5 till when I told someone to start running around. Wait, what is this? Endeavor number 30?
I don't know. Probably.
I think so.
I didn't get a stamp when I came to do homework the one day after school.
I didn't
Alright, Joyce, we're going to pause and do stamps. Because they're not feeling their A game today.
I am.
I got my W game.
WB?
It's been such a long week.
W for
It has been. I
Wumbo.
thought it was Friday and Tuesday.
I've been going to sleep late.
And then
I've been
Wednesday.
waking up late.
And
then
since
Thursday.
2 weeks.
Every day felt like Friday except for
Yesterday I
Friday.
could have sworn it was Friday.
And Monday I was falling asleep because of spring forward.
Ooh.
Stamps. If you want some, I'll give them.
I don't deserve one. It's a problem. I've been leaving the house at like 7:30 every single morning.
Wish I could.
No, I get here on time, but like.
No, I know, that's what I said. I wish I could.
Yeah, I leave
Oh,
the
that's
house
right,
at
that's
7.
what I thought for the other one.
Wait, let's go here.
Like,
Oh, wait,
Yeah.
on April 1st, in week 1 of April, you put it here?
Yeah.
Okay. Thank you, Karen. Karen, if you're watching, love. Just kidding, I love you.
Speaking of Karen, where is she?
Work. Alright, pause. You want to pray? We have 30 seconds for the rest of your day and your mental states.
Please.
UCLA.
Let's pray. Father, I praise you for these kids, and I praise you for just how talented they are, how much you've gifted them with, and the plans you have for their lives. And now, as they're waiting this one college decision and many others, and thinking towards the future, Lord, I just pray that you will just allow them to rest their thoughts on you, to find peace and comfort and strength for whatever may come. Help them to face the rest of this day and what lies beyond. Lord, just infuse in them, shower over them just a sense of your presence and your power and your perfect plan for their lives, whatever is next. In Jesus' name, amen. All right, get out of here.
Miss D, on the lemon escape one, how did you know it was a lemon escape?
Huh?
How'd you know it was a lemon escape from like the
Because
first level?
what would usually happen in the second and the fourth quadrants didn't exist because the square root of a negative doesn't exist. So what would have shown up, like in a 4th rows, isn't
Now I
going
don't
to.
think it's
Because there
Because the
was
square root of a negative
It's like,
doesn't exist.
So once you see that, you should already know the lemon escape?
Basically.
Okay.
That for certain quadrants it's going to be good and for other quadrants it's not.
Alright.
Christy, I stole your charger.